Okay, today's video is on simple machines, and I'll start off with a question with my simple machines. How could you make work easier on yourself? Well, I guess from the title of the video, you probably already know the answer to that. But you might have been thinking, hey, maybe get somebody else to do it for me. That is pretty clever. But that's not our topic today. So how could you make it easier without getting someone to do the work for you? That is a pretty good answer though, but not going to work for our topic here. All right, so machines make work easier for people. I think we know that already. Here's some machines. We are definitely in the machine era. Here's a machine now. You push a button, makes coffee for you. These are incredible times that we are living in, that's for sure. All right, so here's a bunch of other machines, a washer and dryer machine. There's a machine that'll give you food. There's a machine that'll get you down the road. These are all machines that are going to make work easier for you. Doesn't mean that less work is done. It just changes the way that the work is being done. So maybe in the old days you would have to scrub your clothes and then hang them out on the line. And now you can throw them in a machine. It'll wash it for you, throw them in another machine, and it'll do the drying for you. Still nice to put the clothes out on the line sometimes, get that nice fresh air on the clothes. But that's the thing. It's not that there's less machines going to be, less work going to be done. It changes the way the work is going to be done. So simple machines, there are 6 types. There are types of machines are listed here. An inclined plane, a lever, a wheel and axle, a pulley, screw, and a wedge. These are the 6 types of simple machines. You might have heard of them before. All right, so these machines that we're talking about, a person is going to have to supply an effort. They're going to have to do something. They're going to have to pull the pulley. They're going to have to push the lever, something along those lines. This is a picture of Archimedes, whose famous saying was, "Give me a large enough lever and I can move the world." Clever person, Archimedes. Did a lot of work there way back when in laying the groundwork for modern physics. Clever human being. Okay, so really what we're looking at with these machines, whether it's a pulley or a lever, it's lifting something off the ground. So in pulleys, you're going to lift something off the ground. Here's a setup of pulleys, so that's a pretty good idea of what's going on there. All of these involve you pulling something. These pulleys do. That's why they call them pulleys, right? And this system of pulleys over here is interesting to point out because in a pulley like this first one on the left here, the distance you pull the rope is the distance that the object is going to rise. But if you loop your pulleys around, you pull a greater distance, and then the object that you're lifting raises a lesser distance off the ground. But we'll talk about a little bit of why that's significant in the analysis of simple machines a little later. All right, so inclined planes, ramps, if you will, they're also lifting something off the ground. So that's the idea of an inclined plane or a ramp. Here's a happy person using a ramp to load up a truck. It was one of my old jobs. Even a road, if you think about it, is a ramp. You're not going to have a road go straight up a hill. You're going to have it be basically a ramp. And everybody enjoys these ramps right back from the childhood days on the playground. A lever, also you're lifting something off the ground. Here, the pivot point of a lever is called the fulcrum, and then the lever is used to lift things off the ground. Maybe this person can't lift that boulder by themselves, but with a lever, they have a shot at doing it. If you really think about it, you can't pull the brake cable on your bicycle probably directly, but with a little bit of leverage, you can. So again, the pivot point of the lever is called the fulcrum. Okay. So we're going to be talking about work done with machines. And remember, ideally, the work would be exactly the same. The work that you put into the machine and the work that you get out of it. Work input is going to be what the person has to do. What is the person doing to make this happen? And work output is what gets accomplished. And remember, for all of these examples that we're looking about, the work output is going to be something is raised a certain distance off the ground. All right, so we know that work is force multiplied by distance, but we want to distinguish between the work input and the work output. And the work input is going to be the force of effort multiplied by the distance of effort. The force you have to use to push something up a ramp. multiplied by the distance that you push it up the ramp. If it was the pulley system that I was talking about, the force that you pull on and multiplied by the distance that you have to pull the string. Okay, so force of effort is what the force that the person supplies, and distance of effort is the distance they supply it for. So those are the basics there for work input. Now the other work that we're talking about is the work output, and that's what they would have had to do if there wasn't the machine. And in all of the examples I'm giving, it means lifting something off the ground. So they would have had to lift it directly. And remember, if you're lifting something, the force that you supply is the weight of the object. Right? So we'll take that into account. So work output is going to be also a force multiplied by a distance, but since the weight is the force that we would have supplied, we're going to call that the force of resistance. And the idea of resistance might make some sense with weights because they even call it resistance training when you lift something up. That's a way to remember that. So the weight is the force of resistance. And the height that it's raised off, that'll be the distance of resistance. So that'll be the direct motion of what's going on as compared to using the machine. So that is the topic here with an introduction to simple machines. So identifying those four things is key to figuring out all of these problems, and we're going to take it a little bit further in analyzing the machines and the benefits that they supply, but there will be no new variables to use. We'll just turn them around in different ways. And that is the end of this short video, and one more short video to follow on the analysis of simple machines. Maybe it's confusing. If you have any questions, bring them with you to class. And thank you for watching, and I look forward to seeing you there.